No, that's fine. That's fine. Leave it there because they'll show it. Other than if we go straight. Yes. Yeah. Did Glenn talk to you?
He mentioned maybe we should do it over there, and I said, well, I don't know if they'll be.
If you want it, if you want it recorded, you need to do it here. Okay. Then.
I think it's going to be very informal. Just like,
all right.
This is what it's about. It's interesting.
If you break and you move over there, you may lose some people. If you do it here, the people may stay.
Yeah, so I'll just
Yeah.
stay on this.
Yeah.
And I was planning to just come down.
Perfect. Okay. All right. All right. Who am I missing? Glenn. Hey, Tim, you got another mic back there? A runner. Okay, perfect. Yeah, I'm just going to say, can you adjust the camera to capture? Yes, the whole panel. Yes, we are. Yeah. Yeah, so we're moving everything up so that we can get out of here early. Did you find him?
Yes, I did. I thought he was coming. There he is.
Come on up, Gene. Because I'm gonna jump down as soon as.
That's appreciated. I didn't know there's no stairs on this side. So when we do these 5-minute things, I'll give you guys a signal. But I think we're going to be fine.
All right, folks, let's go ahead and start back up. This particular session is going to be a panel discussion. And Gene Lucas, who is president and CEO of Eco Waste Solution and is also the director of SWANA's Waste Conversion and Energy Recovery Technical Division, is going to run this. So, ma'am, I'm going to turn it all over to you.
All right. Thank you very much. Thanks to everybody who's still hanging in there. I know some of you had big nights, I heard. Not going to say, but I heard there were some big nights. And some of us are jet lagged, so it's later in the day, so I appreciate you hanging in for the panel here at the end. We're going to try and change up the discussion and the way we're doing the format here. And we're just going to do kind of like a quick introduction from each of the panelists about the different technologies that they represent. So we've got a mix of different people here. You heard from Dan earlier today, for example, from Shell. You know, he's utilizing a variety of different technologies. These are all experts, and obviously there are only a handful of the amazing experts that you're getting to meet during this conference. But they're going to each give a little quick intro on their technology. We're going to go through them really quickly just to kind of set the stage so everyone knows who the people are and what we're talking about here. And then at the end, I'm really hoping that we can spend time on what are the issues? Why aren't these projects moving forward? We're all frustrated as an industry, I think, and a number of communities, municipalities are also frustrated at the progress among waste conversion technologies. So I think that's what we really want to spend time on. So I'm hoping you'll be thinking about that while we're doing this. And at the end, that we can have a good discussion about what are the key issues and what is it going to take to move things forward in this industry. So to start with, we're going to just talk about, there's a set of questions I've given to each of the panelists, and we're going to do them round by round. So the first round of questions is really, what is your technology? Just a very quick summary, and how does it work? You've heard already, and a lot of you already know how all these things work. So very quickly, what kind of waste can it take, and what can it not process? What is the basic capacity range? So that's the first set of questions. So everyone's just going to go quickly, and I'll just call people up, and we'll cover it, or we can actually just do it from right here. Okay, very good. So we'll leave it to you, Glenn, first.
Got it now. All right. The waste type I talked about just a few minutes ago, so I will go very quickly on that. This is the mechanical biological waste treatment. I'm not going to talk about a specific product here, just generally. The waste type is MSW, including the organics, very important. Separation, you don't have to source separate this, so you don't have to keep the organics away from the MSW. Keep it in the same cart. It makes it a lot simpler, less trucks out on the road picking stuff up. Capacity, maybe you can start around 20,000 tons a year, upwards 500,000 tons a year is no problem doing that. How it works, inputs MSW with the organics in 5 steps. Outputs, we have biogas, RDF, refuse-derived fuels, inert material, and the desired recyclables. That's a real quick thing of MBT, and it's a viable solution out there right now. It's been around, shunned in the past, but possible use right now.
Hi, I'm James Pfeiffer, Green Waste Energy System C6. First of all, we can take mixed solid waste, just as he mentioned. We do have a general preference for separating organics for inorganics, but it's mostly from the point of view of the residue that comes out for no other reason. We can do systems as small as a half, we don't do it per year in terms of my discussions, it's per day, so a half a ton per hour. And then I guess what you'd call the sweet spot are 2 lines, the full lines, which are on the order of 450 tons a day of municipal solid waste, but that figures that there's some stuff in there that we don't want, like Coca-Cola cans or beer bottles or whatever, and that it's got a moisture content. So the lines themselves are actually doing 120 tons a day of, quote, pure feedstock, municipal solid waste that's dry. 2 lines together, there's a benefit from the point of view that you don't need any more people. After that, you just keep adding lines to meet the demand or whatever is going on in the situation. If you have quite a number of lines for inorganic, and it makes sense to have 1 line doing organic, then you just do it. It's not a big problem.
And James, can you just tell us again, what are the technologies your company builds? The specific types?
So there's, first of all, we run it through autoclaves, which we actually build. That's to basically clean it, then we dry it, and we pulverize it in that process or make it into like a fluff. Then we run it through the pyrolyzer, which is our technology, and then we clean it in various stages, as I showed before, and it's the synthetic gas that we use in engines to either make electricity or process it further via Fischer-Tropsch into liquid fuels like sustainable aviation fuel, ultra-low sulfur diesel, and fuel oil.
Okay, very good, thank you.
My name is Michael Kleist. I'm the VP of Business Development for Sierra Energy. I'm the only technology up here that you haven't heard about yet. So we are a ultra high temperature, updraft, fixed bed slagging gasifier, right? That would be the definition. So yeah. So by high temperature, we reach about up to 4,000 degrees Fahrenheit, so 2200 C. Similar to plasma, but we are not plasma. We reach temperature in a chemical reaction. So we inject oxygen and steam at the base of the vessel. The oxygen reacts with the carbon and waste. That's the exothermic reaction. We create syngas. So in our system, the organics will go into synthesis gas. Some of that syngas will be recycled back around to keep the gasifier running. The inorganics will melt into stone or liquid metal, so we are a slagging gasifier. Because of the high temperature, we can take just about every type of waste. Truly, we prefer mixed waste. So our design is focused on heterogeneous waste. The type of mixed waste, mixed plastics, cellulosic, adhesive, all of the stuff that maybe shouldn't be going into a pyrolyzer, that would be us. We do have a fully integrated commercial scale demonstration system up and running in Monterey County here in California. So we use that to run feedstock for our upcoming license partners to run their feedstock through the system. And lastly, system size. Our vessel commercial size is 100 metric tons per day, and the ideal project would be 200 to 500 metric ton per day system size, and we focus as the technology vendor. We are not project developers.
And I'm Dan Falla from Shell. We're quite vast in the different technologies that we're interested in and that we're working on. RNG from MSW, waste organics from various applications, forest products, you name it. But the area that I've been focusing on myself in the last little while has been pyrolysis from waste plastic. Primarily polyethylene, polypropylene, a little bit of polystyrene. So you pyrolyze that and it pretty well will for sure meet our cracker specification for our Norco refinery. And the capacity to that particular facility is quite large. It was designed to handle Venezuela crude and can take the heaviest waxes all the way up to fairly light hydrocarbons. So a lot of the technologies that we hear about in terms of catalytic conversion for pyrolysis, et cetera, we don't need to go to that degree. We can crack it using our facility. And then once it is cracked, it'll either go into a variety of chemicals, surfactants, and you pretty well name it. Preference is obviously to go into plastics because that's where it originated from, and we're actively working with the brand owners, the converters, and the rest of the industry trying to find home and find sources to meet our needs.
Right. Thanks for that summary. So it sounds like you guys can all handle a range of technologies. Some of you have a range of capacities, but some have a pretty specific range. So it's really, I think, helpful information for the audience because at this point in time today, we haven't really heard that. So that's really great. I appreciate that. So that goes perfectly into the next round, which is really about what is the sweet spot of your technology. You guys have started to touch on that. Please tell me a bit about, or the audience, what is the perfect application for your technology, whether that's community waste or a specific profile of the waste, the type of waste, the type of infrastructure that might need to be in that community to adopt your type of a project. And then also, if you could just give us the other side, what are you absolutely not thinking is a good feedstock or a good application for your technology? Go ahead.
Good, I'll start with that. The sweet spot. Again, it's MSW with the organics. The real interesting part about this is the high diversion of the organics from landfill without having to separate the organics from the waste in the beginning. So there's a lot of advantages there. We went on and talked about that before. It can be located in rural areas and close to the waste producers, so you don't have to put such a plant out in the sticks. I used to live 300 meters away from the plant I was working at and didn't see it, smell it, or hear it. It can be located close to the logistics that are already there, so you don't have to reinvent all the logistics for the waste and have it right there already. Co-located with the end users of the biogas or RDF. If you want the RDF brought to a cement plant, maybe co-located in an area where a cement plant is already. That's usually a little bit further away because of the noise and the dust from the cement plant, but it could be co-located there, which would make sense. And there's also no contamination issues with the organic components. We heard a lot about that today, contamination in my organics, plastics and everything and metals coming in there and how to get rid of that. It's a sensitive thing, especially in California. It doesn't exist with an MBT. Collection, one less organics cart to collect and also increase safety. You have one less truck out there collecting organics, fewer accidents can happen. You don't have to change your current waste collection scheme. Yes, an MBT as such can be SB 1383 compatible, and it's designed to fit the waste that comes to it, not the vice versa. You don't have a box that you just have to, the waste has to fit it. It fits the waste. What wastes are not really compatible to this technology? C&D. You don't want that C&D rubble in there. You don't need the stones and the non-organics. Only the non-organic waste shouldn't be in there. So we want the organic with the MSW. Hazardous waste, that shouldn't be in there. One reason is that there are people working in there, and getting in touch with hazardous waste like medical waste is probably not a good idea. If they're even there with safety gloves and walking around with masks, there's certain things you might get off dialysis machines that would not be good to have there. Bring that the current way it's being taken care of, usually to incineration, also with the sharps, take care of that in the current way. It's much safer for the workforce. Bulky waste, unless there's another way to tackle the bulky waste that shouldn't come into it. Inerts, sand, stone, pebbles, glass pieces. Only liquids shouldn't come in. It could be very soupy wet waste, but just the liquids, it's not good for that. And you also don't want sewage to come into the whole system. Sewage, because people are there too, getting in touch with it, it just won't work very well.
Can I just ask you a question about some of those things? You mentioned medical waste and hazardous waste and sewage, with respect to the workers. Is this an automated process, or is there some amount of physical sorting? Is that why you're concerned about it?
There is quite a bit of automation in there, but there's also hand sorting.
Okay.
Okay, we don't have, like you see in a typical MRF, with 10, 20 people standing on fast-moving conveyor belts, breaking their arms trying to get stuff out of there, which can be dangerous and dusty and all the rest. There's 2 or 3 people on the sorting tables, much slower, in good, clean conditions, but they still could come and grab sharps if they were in there, which isn't a good idea. So take care of them.
Right. No, medical waste usually goes separate ways, but of course it can end up in a plant, so I just wanted to ask.
And sewage coming in doesn't make sense because of all the bacteria and colibacteria and who knows what in there. Keep it away from the people to be a safer have a safer workplace.
Thanks, Glenn.
Okay, so we're not a whole lot different. We don't really want construction debris, which a lot of time is drywall and things like this that don't have a calorific value. So from that point of view, we're very similar. We're going to process the stuff, the calorific waste. So something like medical waste, I mean, this is where we differ, one area. It's when you think of medical waste, it's mostly gowns and plastics and things like that. There are obviously some syringes. The syringes are pretty small in content. Just throw them all together. The autoclaves will kill anything. The separator before the pyrolyzer will reject the metal, so it's fine. We can do systems, as I said, as small as a half a ton per day, so that would usually be something that's more or less focused on a single stream of waste, but it doesn't have to be. We can do, our lines are 120 tons of pure feedstock, dry feedstock, so 2 lines is sort of a sweet spot from the point of view that it's no more people for 2 lines than 1 line, but it's just from that point of view. And then multiples of that. So somebody like New York that's got 1,000 tons a day, we put in 4 lines or whatever, 6, whatever it is. What else is in here?
So is there a specific application you're targeting directly?
Oh, so our main target is municipal solid waste. I mean, let's face it, that's what there's most of out there. The stuff that we have all in development, through various parties, is all but that, which is frustrating to say the least. There's a group doing wastewater treatment sludge, as was just mentioned, in a special setup to dry it. Looks as if there's going to be great payback in it because so much of it gets dried, and instead of going to a landfill at X number of dollars a ton, in this case, you're going to get some power out, which is going to go right back into the plant, and you're going to have this residue, which is pathogen-free, which is not going to go into a landfill. It's going to, go to farmers' fields and stuff. So there's a version that can just process tires, but then you're talking about a specific version, just to lay tires down on a bed and have them processed through and just get out metal and lots of really high potent gas. which you can do a number of things with. So, but, you know, what I really want to see is if anybody out here has got the application, is I want to build an MSW plant within 50 miles of Manhattan. And I think that'll change everything when people see the system run. So.
High temperature gasifier, probably being able to take mixed waste is the advantage. So if we do get some metal, glass, that will melt in our system. Obviously it's not creating any energy, so you would like to take that out. But if an aluminum can gets in, we will melt it and you'll have a blob of metal on the bottom, which is not what you want. It's also good for mixed biomass. There are certain types of biomass when you look at a low temperature gasifier or other processes that have a low ash melting point that could create a lot of tar and sort of gum up a low temperature gasifier. That will not happen in our system. So again, that's the advantage of the slagging and the high temp is to take the different wastes. She asked about an ideal project, and as a company that's just commercializing our technology and getting into our first license agreements, we don't really want to be the waste to energy only technology right in the middle with everything relying on us on our very first project. So our first licensing agreements are with larger developments. One is the perfect application and infrastructure is it's an electrolysis play, so there's wind and solar at the site we're licensing into for electrolysis to hydrogen. The plant is making ammonia. They also have biomass there that they want to gasify for extra hydrogen. So our technology would take the oxygen that they're venting from the electrolysis and the cheap energy to, and the biomass in our system to create additional hydrogen to go into the ammonia, and then the very clean CO2 stream we have reacts with ammonia to create urea. So you're looking at a very large project where we are a piece of it, but and that one is actually a 100 ton per day gasifier. We're able to produce hydrogen at under $2.50 per kilogram to meet their requirement. So the ideal project is not necessary for us to be straight waste to energy. And the second project we're in is a large oil and gas company in Europe. They're building hydrogen fueling stations. They want hydrogen for municipal solid waste. So we're taking the MSW. They also have pyrolysis, and we're taking the pyrolysis residue, and those are going into our reactor. And again, the nice part is we're not the developer. We're just the gasification technology. So they have their own hydrogen offtake for their own filling stations. We don't have to worry about that. And so that kind of infrastructure sharing really can drop down the price of a system. In our early stage, putting a 100-ton gasifier on a greenfield location gives me nightmares. I mean, I just don't see that, penciling out early. And then lastly said, don't like feedstocks. I would say we don't like super wet, so 20% moisture and under is best. We have low-grade waste heat that can dry the waste. Also, if you have waste with super high volumes of ash, all you're going to do is create a lot of slag that won't create energy, so you'll spend money to turn stuff into rock. It's not an advantage. So.
Before you give it, Dan, I have a question for you. Would the RDF be interesting feedstock for your system?
Yeah, absolutely. And actually at our demo facility here in California, we have run MSW biomass and some, what we're calling in California, engineered municipal solid waste. Yeah. It's California, they can't call it RDF. I don't know why. So we have
Someone said Californians are crazy, but
yeah.
All right.
And so we have run that through, and that obviously that's a great feedstock.
Thanks.
Yeah.
What was the term you called again? Engineered what?
EMSW, if it's engineered municipal solid waste, which is what they're selling. They created that to sell into cement kilns. So that's what the kilns are running on. Yeah, crazy.
Okay, this is too technical for me. So there's a few different areas, as I've mentioned, that we're involved in. That's hydrogen over in Europe, and as you mentioned about the fueling stations, et cetera, that's part of what we're doing. Refuse-derived fuel, okay? Biomass into renewable natural gas. But as I said before, the main thing that I've been focusing on is pyrolysis oil that we would send to our cracker in Louisiana. We're not going to operate our own facilities. We do have an equity stake in Blue Alp for pyrolysis, but in North America, we've preferred to go with more offtake agreements with partners that can produce a product that would meet our cracker specification. And it's a fairly tight but yet broad specification. Obviously there's chlorine that we can't take in there, and there's other types of elements that can foul our catalyst at the plant. But we're going to be in an offtake position that if you can produce it and it meets our spec, we will take it.
That's great.
With not much limitation in volume at this point.
Good. Okay, good. That explains things very well. So now we'd like to just talk more about what are the results really of using these technologies. I think a lot of people realize that they have broad applications and they can produce fuels and things like that. But now I'd like our panelists to maybe talk a little bit more about the types of products that your technology is actually producing. What are the valuable byproducts that come out of the technology? And how much energy per ton, if you can give us some metrics like that, and net ideally, and also who's buying these products, because a lot of times we talk about RDF and we talk about other things that potentially have value, but I'd like you to just talk about the markets, maybe markets you're familiar with or markets that you're already selling your products to right now, just so we have a good sense of if they are truly valuable byproducts. Thank you.
Okay. Net energy produced within MBT technology, the energy itself is zero. We produce energy carriers in form of biogas and RDF. So we don't produce it itself, you have to utilize it somehow to create the energies and maybe change it to other things that we talked about before. SAF, use it as a feedstock for yours, Michael, would be really very good. Byproducts, as we talked about before, biogas, 71% methane content, very high, a lot of energy in there. Thermally utilized for heat and electricity, converted to RNG, to hydrogen, to SAF, sustainable aviation fuels, and as I said before, on the side, a little cryptocurrency as well. One of the byproducts is also RDF, very nice and dry, 10% wet. Thermally utilize it, so burn it, maybe to create power, to create methanol, ethanol, in gasifiers and pyrolysis to create the syngas, and also in central heating and power plants can be used. The other products, byproducts out of the MBT are recyclables, which you can take out and bring back in the circular economy, inert materials, and what people are buying it, power plants, RDF plants, and cement factories. The situation I've learned in Germany as experiencing there, we would send a truckload of this RDF to, for example, the cement plant and deliver money with it per ton. Why? That's the market there. But it was a hell of a lot cheaper to do it that way than to bring it everything to incineration, which would cost quite a bit more to take care of it. So bite the bullet, pay a little bit, but quite a bit less for each ton to have properly used and utilized in a way.
I know you're familiar with a lot of the projects in Europe, particularly in Germany, and can you just tell us a little bit more about who's buying that RDF that's being generated there, and is that helping to fund these MBT plants, and can you give us any sense of metrics in terms of what it's valued at? Because
we're not paying for it, they're not buying it, but they're buying it for negative money, so we pay the money. We're not funding these MBTs with this kind of money, but the MBT is funded through, or the one I was working at, via the tipping fees that are brought to it, paid for by the citizens. Because the ZAC in Germany is also a communal company between the two counties it serves, it cannot make a profit. That could be two different business models in the States, so you can have privately run, but because it can't make a profit, any costs it has give to the citizens. And we're strong enough to say, okay, any savings we can get, we have to also give to the citizens. So the cost used to be, I think, 96 euros for four-person household a year. Now it's down to 91. We reduced the cost
So that
because we
covers
made more
100%
efficient.
of the operating costs
Yes,
of the
there's
plant?
no subsidiary money from the government to help pay for it. It's all 1-to-1.
And what's
right
the
on in there.
population base on that?
385,000 people, creating about 105,000 tons of MSW with the organics per year.
Okay.
So
great.
it's a number you can really work with.
Yeah, thanks, that's helpful.
So we just produce a synthetic gas or syngas and then have about 12% residue. The synthetic gas itself can be used in engines to make electricity or processed via Fischer-Tropsch into liquid fuels. That's it. There's the only two things that we make. The residue is inert. It can be used for a number of things unless you do separate out the organics, and then it's basically a soil supplement. So in terms of the energy values, when you are processing something like municipal solid waste or wood as your primary feedstock, and I do everything in terms of electricity, but so it's 1 megawatt per ton. That's just the way we look at it. I mean, there's various ways to convert that, but when you have something that's high in waste plastics, it's more like 1.6 megawatts per ton. When you have something like tires, it's going to be even higher. It's pretty straightforward that way.
Also produce either syngas or, as I mentioned before, liquid metal and non-leaching stone. So with syngas, you'll see a lot. You can produce all sorts of things, right? That's what you always hear. The reality is what I'm seeing in projects that we're looking at and getting into, there are really three outputs that make sense. And that is hydrogen, methanol, and RNG. Electricity is the easiest. I don't see any project at a couple of hundred tons per day of waste that electricity project will make money. When you're selling electricity at 4 cents and 6 cents a kilogram, forget it. Fischer-Tropsch, SAF, ammonia, all of those obviously can be done from synthesis gas. They're just really expensive back-end technologies. So I don't see us at our size of 200 to 500 tons per day doing that. For us, putting FT on the back of our system, you're going to need to be huge to really make money on that. That's what I'm seeing. And those are the projects we're involved with our technology. The energy value, so for a 100 ton per day gasifier, we've had to do this going to FEL2, the engineering step for a project. For hydrogen, we'd be about 10 metric tons per day of hydrogen for a 100 ton per day of waste. We'd be about 1,300 MMBTUs of RNG on that same system, and we'd be about 40 to 50 metric tons per day of methanol. But all of this does, as you just mentioned, depend on the feedstock and the configuration of the plant, right? If you're recycling syngas around to create your own oxygen, which we need, those volumes go down. So there's a lot of stuff in the plant itself, that you have to consider.
Okay. Back to what the original question was. Could you repeat?
Sure. It's really what are the results of the technologies that you're producing? If you can try and put some metrics around it, it's great. Just in terms of who's buying these end products, what are they being able to be sold for, and how much energy do you put in and waste do you put in and how much do you get back out? Those kinds of things would be great.
Okay, so I'll focus on the pyrolysis oil side of it. So it's a little bit of battle inside of Shell because I'm part of the chemicals group, and which is also part of the polymers group is part of the chemicals group. And if you look at our entire infrastructure, we have upstream, we have downstream, we have chemicals, we have a whole variety of stuff. Deep well drilling out in the Gulf, et cetera. But the area that we're particularly focused on is the plastic and pyrolysis oil that comes from that. So the battle internally inside the corporation is, where should those molecules go? We're following the mass balance concept. We're certified ISCC plus, both upstream and downstream from us. So our suppliers have to be ISCC plus certified, and their suppliers of the waste plastic feedstock have to be as well. Also our converters, if we produce this into plastic again, they have to be ISCC plus certified. So the battle inside the corporation is, where should that carbon credit molecule go? Should it go into making urethanes? Should it go into making surfactants? Should it go back into making plastics? What is the vehicle of where to put that carbon? And it comes down to economics. Plus there's also some egos that are involved inside the corporation. So as to who's going to sponsor what application and drive what project is really where we're going. So the ultimate consumer is us, but who supplies us is the CPGs. So the Procter & Gamble's and Johnson & Johnson, et cetera. So it's going to be up to them to decide what they're willing to pay in order to get the feedstock that they need in the format that they want, whether it's a surfactant, whether it's a I used to work at Dow. Dow, we sold the trade name to SC Johnson, Ziploc bags into something like that. So what is the best vehicle to go into? So if you look at the plastics industry, probably the most advantageous market segment itself, that's the biggest challenge for mechanical recycling, is going into food packaging. Extremely difficult to do mechanical recycling and put it back into food packaging. The traceability of that whole thing is just unbelievable. But if you do the mass balance concept, unfortunately, the Ellen MacArthur Foundation published a report or a white paper on the advantages of mass balance. Without that, plastics recycling would be an extreme big challenge to do things. So food packaging is probably the ideal end-use application for sustainable polyethylene is what I'm going to call it. Mechanical recycling probably is going to go into non-food applications such as trash bags or grocery sacks or things like that. So it's a battle within the corporation as to where those carbon molecules should go for the best value for the shareholders.
Great. Okay, so that gives us a really good understanding of the technologies and applicability and the results. And now I think a lot of these technologies we've been talking about, a lot of them have been around for a long time. I'm hoping that each of you can kind of just give us a sense of what are the advancements as you see it. A lot has happened in the last 5 to 10 years. So I'd like to just touch on what's happened in terms of the effectiveness or the efficiency or reliability or clean outcome in terms of emissions of these technologies, and because I think that's important for everyone to just think about that. I mean, we know these things have moved forward, but then what's stopping them from advancing? And that's when we'd like to kind of kick off the audience discussion from there to talk about how we can move these projects forward and move the needle in the industry. So if we can just talk a bit about advancements, how it's gone, and maybe also what you've seen in the industry in terms of the market uptake or new regulatory things that are happening. Just in general, if you can set the context with that, it'd be great. Thank you.
All righty. Some of the things that this technology, the MBT technology, can do is also create a lot of biogas. 6.5 to 7% of it, the original weight, can be converted to biogas, of course, in cubic meters. It's a very high diversion of organics from the landfill. We've said that a number of times, but it's very important to know that. The sludge from the fermenters, doesn't have to go out onto the fields. It can be used in the biological drying step. Make good use of it and don't have the problems that you have with stuff going out into the fields. There's also no contamination issues that we're facing with the organic components. With organic bins, a lot of the plastics and other things in them that they're having trouble getting rid of. High reliability. These plants can work as long as you control the process and know what you're doing and understand it. You don't have to be a rocket scientist and a PhD to run these things, but you have to know and be able to think to run these plants, and you can have them run for a long time. Good ROI on them. You want to fix it also before it breaks. Do some preventive maintenance, and the O&M on it is no higher than any other kind of plant that you might have, as long as you keep it running. Think of it like your nice car. You want to keep the oils and waters and all that sort of stuff up to date and serviced so it lasts longer, make more money out of it. Or at least you don't have to spend more money on a new car. It can be a very safe work environment, very important these days. Extremely low emissions. People can walk by such a plant and can be located close to rural areas and housing. Or as housing encroaches upon it, it's usually not a big problem. What are some of the changes that are needed? I think we would really like to see that there's a top-down, and this is generally on a lot of these technologies, a top-down from the feds. Possibly, we've seen it, how it works in Europe. It's a different situation, I know, in the States, and also a little in Canada, but they're also in that way as well. Top-down from the feds saying what should be done, not how, but what should be done. And renewed look by the municipalities at this technology. Very often you come to the mindset, well, we've been doing this stuff for years, and this stuff for years, it's working, and I don't know what's out there. There are things out there that we're talking about here in this panel that are working these days. Let the municipalities start to look at that to make their decisions on what they want. And create the understanding that an MBT is not waste to energy carriers, if you will. It is waste conversion, which we all want, and it's not incineration, but is an established technology.
Can you just speak just a little bit to if you see any signs of hope out there, or any specific things that you can say that are that we need to change right now?
There are signs of hope at different conferences. I was just recently in Florida at one of the local Florida chapter, SWANA chapter conferences, and counties just didn't know, and talked about it and said, oh, that's what it does. Oh, that's interesting. Well, we kind of need that. But there was only one person there that said, our county, WTE, not interested. He came out straight face and said, no, we don't want that because we have WTE, our investments are there. At least he said that, and I don't have to go and try to bug him about and try to do the sell and the pitch on it. But it was interesting. There are people said, oh, we have so much waste, our landfills are overflowing. Let's go to this and maybe open their eyes, or they're opening their eyes, know that other technologies, like we're seeing here today, are available.
So part of it's awareness, in
Yes.
your opinion? Yeah, okay.
So I see the future of this stuff as being really interesting. I mean, first of all, landfills are closing. Incineration plants are being closed. As I said, the state of Connecticut exports all its waste. Every state can't do that because then it's got nowhere to go. So the future of the general technology, is tremendous. And when you think about it, for the most part, certainly with our stuff, it's a negative emissions technology. Now, so when we make electricity, and electricity is just the easiest thing to use. We make other stuff, but let's just take electricity. When we make electricity, we're displacing electricity from fossil fuel power plants, which are the second highest emitters of CO2. So we've displaced that with something with, you saw before, much, much lower emissions. But we're also displacing methane emissions from the stuff going into a landfill. So we're displacing two different sources of emissions with one that's very small. So by the way everybody counts this stuff, we have negative emissions. Where can this stuff go? It can go all kinds of things. As I mentioned, there's a special version that can do tires. I mean, if you start looking around, there's tires in various places piled up like small mountains. That can be all clean energy. One of the really interesting new areas is that coal finds have rare earth elements in them. And we have all this push right now to be making our own chips and all that sort of stuff. We need rare earth elements. So when we process the coal finds, we increase the percentage of those rare earth elements by 6-fold. we're not done. You know, you're not done, but you're a whole lot farther along than you were before. And then there's the whole thing about PFAS destruction, which is kind of an enigma. As people have said, it's hard to say how much there is, how you define it, and all that. But at our temperatures, once we test it and prove it, we're going to find that we do destroy PFAS. So that's all important too. And you just think of how much waste there is out there, and converting it to energy, the implications are just tremendous. That's all I can say. They're tremendous.
For us, I'd say the advancement is, as a company that's developing a technology to get through the valley of death, right? So we got funding from the CEC to build our demonstration plant. It was harder than we thought. We really needed to get Series A investment, which we got of $33 million. That's the kind of thing that was needed. That was the advancement we needed, was money to build that and operate the demonstration plant, because if you're really trying to get a technology out there have been a lot of failures in gasification, and they want to see it working. And they want to see it working on their own feedstock. And that's what we needed to do. As far as markets and regulations, advancement, electricity was going down in price, so that was something we thought was going to be good. We don't see. But then the hydrogen economy coming out is helping both in California and abroad. And also, I mentioned earlier methanol. We're just the technology developer, but things like Europe's Fit for 55 program, where they're saying ocean logistics get benefits by replacing bunker fuel with the methanol. That is helping us, because developers can look at, MSW to methanol. And other things, like places like Korea have passed laws saying hydrogen from MSW is clean. They're not calling it green or blue, they're just saying it's clean. And that's a helpful advantage. And then more in Europe than the US, Europe takes more of a mass balance approach and says, okay, if you have MSW, we're not just going to say, like in the US, that converting MSW into hydrogen is dirty, you can't do it, or you're not going to get any credits. They'll look at it more, you get a portion of the cellulosic part, which would create methane potentially in landfill, and the plastics we'll get dinged on, but they'll view it from that mass balance approach. And those are the kind of things that I think will help us.
So one of the biggest challenges that we face, and what I've been doing for the last year and a half, is I've been the waste plastic feeds. Okay, this is part of the job title, and I can't put it on a business card. Waste plastic feedstock acquisition strategy lead. So it's trying to find the waste plastic. We know there's a lot of it out there, but it's trying to get it. And it's been a major challenge in North America, because recycling rates are so low. Like, for example, there was a report that was published a couple of years ago that showed the city of Houston recycled only 11%. So 11% of the population was actively recycling. So that's a major challenge in that region, trying to get that waste material in for our pyrolysis partners to convert it into an oil that we can use downstream for a variety of applications. And that's probably one of the largest limitations that we have. The other part is the acceptance of government officials on technology that's acceptable. There's 22 states, I believe, that have allowed and deemed pyrolysis as a viable mechanism. California, this one I'm still trying to understand, that if you pyrolyze or you export plastics that's pyrolyzed out of the state and then convert it back into a plastic, you cannot claim that it's a sustainable polymer. If somebody can clarify that for me, the rules and regulations, that would really help. So the government confusion is there. Again, as I said during my presentation, you can't bring data to an emotional argument, and that's a really good example of that kind of a scenario.
Right. Great. Thank you for that. So it's good that you guys were able to give us a good overview of some of the challenges that you're experiencing, but also there's obviously great opportunity. We're all here because we believe that too. And so first of all, thanks for holding your questions, and you may have specific questions based on the content that was delivered here, so by all means let me know if you want to ask any of those. And also, if you'd like to just give us your feedback, your thoughts, or questions for the panel regarding why these projects are not taking off and what specific measures we could see or changes need to happen in order for things to get better. That's too big of a question, perhaps, for everybody to get into. You know,
Part that I had
please
done.
do. Yeah.
So I talked about the challenge of getting that waste plastic feedstock for our offtake partners. The other challenge is finding the offtake partners. Is every single pyrolysis producer today, and there's just a handful of them that can meet the specification for our refinery. They're all demonstration size plants. There's nobody with anything of substantial size. There was one company that announced a massive project that went a fair ways along. They're still 2 years overdue in actually being commercial. So that's one of our biggest limitations. Is we have the demand from the CPGs and from the consumer, but we can't meet that demand because there's not enough volume out there of people being able to do it. I call it the chicken and the egg. There's not enough waste plastic and there's not enough pyrolysis oil producers in order for us to meet the CPG demands that's being put upon us.
And as Michael mentioned, it's that commercialization, right? Getting through the valley of death, and how do you get your technology to that point?
You need funding to get there, and to add to that, it's the same issue with hydrogen, right? I mean, everybody's saying we want renewable hydrogen, this kind of thing, but you try and build a hydrogen project in California, and you got to have your offtake. Would your Shell hydrogen guys? I've talked to them. I mean, they are going. You're building the hydrogen stations, but you don't know the exact volume that's coming. And if you're trying to build a project here and get it financed, you need a long-term offtake contract. So. Fortunately, we're the technology, so we're letting the project developer deal with that. But, you know, that offtake contract is critical in getting a project off the ground.
Right.
It just is.
Yeah, as you said, in the long-term contract. And you brought up hydrogen, and you know, right now when you talk about electrolysis or other forms of hydrogen generation, everybody's talking about green hydrogen. Don't necessarily consider waste conversion to be green hydrogen. What do you think needs to change there in order to see more waste projects supporting hydrogen?
Well, in the U.S., it's just not going to be, well, first of all, the thing that would have to happen would be carbon capture and storage. That's the only way to take municipal solid waste, make hydrogen, sequester the carbon, and then you're okay. So that would be the answer there. In the U.S., otherwise, it's credit chasing and biomass. So you see all these technologies going to the biomass feedstocks that, you know, will give you that low CI score. And there's also, if you look at the DOE has their loan program office, the USDA has loans. Every one of those are targeted to a biomass feedstock and a, you know, clean, you know, output. So if you're trying to do MSW in the US, you're going to lose all those credit dollars. You just won't get them.
Right. So you're kind of looking for private investment and other people to move things forward at this point in time.
Yeah, I mean,
it's the government's job to invest these.
Sorry, but that's what we have federal and state governments for. They should start picking up the ball and saying, we need to address this issue of waste. We've got all these people who say they can do these things. Nobody wants to be number one. We'll be number one. We'll fund a plant, you know, on a, you know, Fresh Kills landfill or wherever the heck, and you know, prove it that it works. That's government's job. That's what government is for.
I'm going to add to that, though. I think what you're, sorry, I'm monopolizing here, but what you see the government looking at is they're not talking about waste. They're talking about GHG reduction and carbon reduction.
Right.
That's why all the credits are going to the biomass. They're not looking at the waste problem.
Right.
They're looking at.
You don't hear a lot of discussion about the waste
greenhouse
problem.
gas reduction.
Of course it is, yes, and we know about the
Except if you've gone through the DOE loan program thing, you'll look at, if they took waste wood, we looked at this specifically, painted C&D wood, which has to be landfilled by law, going into gasification, they come out on the DOE and in the LCFS CARB as it is better to bury it because it's sequestered in a landfill. So you don't get the negative score on that type
I
of
see.
feedstock. So
that's
that's how the loan office is looking at it.
Right, that's a challenge. Does anybody else have experience with those same kinds of barriers? I think that's the big challenge right now. We're seeing, as like James, you mentioned, you'd like to see the governments fund some more of these pilot projects and help companies get to the point of commercialization. But in the end, it still comes down to the markets, and it has to be a viable product. Go ahead, Dan.
Yeah, there's been a few black marks out in the industry with people promoting their technology as being the next best thing out there.
Right.
And when you come down to it, okay, let me use an example. So I do a lot of screening of the pyrolysis companies in order to supply feedstock. There's one little thing that I do that is kind of a trick question, and that's understanding what their growth plans are. And there's a number of companies that I've talked with that, yeah, we're going to go modular, we're going to do 5 KTA, 10 KTA, et cetera, in various modular strategies. Okay, so what are you planning 2 and 3 years out from here? Well, it sounds like they all played hockey. Because you see that classic hockey stick approach. You start off,
Yep.
I'm going to do 2 or 3 units, and then within 5 units, we're going to have 300 or 400 units out there in the marketplace. As soon as they get to that point, conversation's over.
Right.
It's just proven over and over and over again. It's a cash grab, and that's probably the biggest challenge with a lot of the companies that are promoting technology is they don't have anything really to back it up, other than the fact that it's worked on a bench scale. It's worked here. You've used a supercritical fluid that's cleaned out the contaminants out of this particular polymer. But once you take it beyond a bench scale, it starts falling apart. There's some other very large corporations that have that announced that they're going to make massive investments into this technology. Then you start pushing the limits of thermodynamics, and you can't break the laws of thermodynamics no matter how much you try or how close you get to it. And there's so many black marks out there that it's hard to get the funding from people that believe in it. And if you actually do have a technology that's proven, in order for it to actually happen, you got to bite the bullet and find funding to sustain yourself to prove that your technology works at a demonstration size plant. And I'm talking probably 15 to 20 KTA of oil. Once you get to that point and you can prove it out, then you're okay. So this in Canada it's Dragon's Den, in the US it's Shark Tank. So if you follow the strategy of Shark Tank, you got to prove that you can actually do it before they're going to give you the funding. If you come in with an idea, no, they're going to throw you out. You have to prove that you've demonstrated your commitment, you've put the sweat equity into it, and you've proven your technology works at a much larger scale versus a mini plant. And that's my biggest challenge in trying to find pyrolysis companies, is that they have proven technology versus something that's just on paper.
You just pick up on that, Dan, not about pyrolysis, but what I experienced in Europe. I think I mentioned it before. There were 2 MBT plants that were built with another process in Europe. They built them completely. They started to run them. They tried to run them. The process itself, they said it's going to work. They tried it maybe on small scale. They built these plants, and there were tens of millions of euros that were thrown into the sand. And they couldn't get this process to run, and they had to stop it, dismantle them in Heilbronn and Buchen in Germany. And the process that I was working at, it's MBT, it was designed to run, and it does work. And so it is tough, because when people do hear and see that, oh, it's working out there, and then it doesn't work, it gives it a bad name right in the beginning, and they're very, very cautious about taking on this again. And we're happy that my former boss, he did this, and he could explain that it does work, and we did try it, not just build a completely new plant, but tried out our theories and made them work, to spend a couple of years doing that, and it did work. So
And
it is difficult.
I would add to both. You hear a lot, at least in the gasification space, we got this gasifier, then everything else is off-the-shelf technology and it runs. When he says, I believe, demonstration plant, you mean fully integrated, showing not only the, what happens for us at a gasifier, but what happens after it, and that it can integrate and actually produce the end product desired. And so having that fully integrated, you hear a lot, we're just going to put ours in there and everything else is, off the shelf. And it needs to be proven.
Yes.
I can only say, again, this is where government is supposed to step in. For $7 million or less, you can take in 25 tons a day, and actually that's after it's dried, so 30 tons a day, 35, and produce inert residue, produce enough synthetic gas to make 700 or 800 kilowatts of power continuously, and for people to look at it and see it run continuously and go, oh yeah. But nobody wants to be number one for good reasons, or all the stuff that was just cited here. So that's the role of government.
But there certainly are projects that we've heard about today, and all of us know of, where there was a lot of money kicked in from the government. And there's a challenge because, of course, a lot of times you're dealing with small companies, as you mentioned, maybe have unrealistic ideas about the future and how to get their technology commercialized. Maybe it's not just about money, because there are a lot of examples where lots of money, in Canada we have examples many people may have heard of where, hundreds of millions of dollars got poured into moving technology forward, and in some cases people associated with the company did all right, but in the end there was no technology to speak of coming out of it, and maybe some incremental progress was made, but that's debatable. Certainly in the end, no technology became fully commercialized out of it, and then the investment community and the government both kind of start to take, a not as good of approach to those types of projects. So I don't know if it's maybe more than just money. Maybe it's technology incubators or other things to support these generally smaller companies. Because I can say I've been working in the waste industry now for a long time, and it's been over the decades. I've seen a lot of these companies are gone. In fact, vast majority of them are not around anymore. So it might not just be about the money, because I do have seen at different cycles in the investment community money coming in, and same with government. So maybe there's more to it. Other things we could do to help move these things forward. Do we have any questions from the audience? Again, I thought I would ask. Yeah, good.
Hello. Thank you for your presentation. I have a couple of questions, might be probably ideal. We talk about the technology, but we also, like you say, the numbers. What are the CapEx and OpEx numbers of your technology, so we can get an idea about how much it costs to run these type of technologies at a larger scale? The other question is, if the end product of your technology, it's able to use by itself, or we still have to mix it with oil. I mean, like the biofuel, does it sustain by itself, or it has to be still used with regular oil? And my third question is, we talk about biofuels, but I don't know if the industry has looked into beyond biofuels. I know there are studies about bringing the carbon through carbonization and create nanotubes, carbon fibers. Is this something that your technology has looked into?
So maybe start with the CapEx, OpEx question. Does anybody want to dive in? Now, some people, one of the issues that we talked about here is the fact that not all these technologies are commercialized, so demonstration plants don't often have the volumes necessary to be able to prove out a business case. So in theory, if they scale up, they may be viable, but at the bench scale may not be. And then, of course, there's a lot of what ifs when you're dealing with commercialization, but maybe, do you guys have any metrics you can share?
On the CapEx, OpEx on the MBT that I was working at, if we were to rebuild this plant now, that we started in 2006, and some iterations going on the way until it was called MYT. If we were to rebuild it now, according to MYT, it would cost around 62 million euros. Based on German costs. Have to be careful on that and don't always compare it to US. So German costs 62 million, what's that, maybe 65, 70 million US dollars, based on German costs, labor, materials, insurance, and all that sort of happy stuff. It will be different here, but you can get a lot of the equipment and source locally here. And operating costs, operating and maintenance, about 5% of the original cost per year. It's a standard for such facility as I understood. The trick is, do it right the first time. Maybe put in a little bit more in the beginning, put in the right equipment, put in the right materials, use the right steels that are in contact with corrosive materials and waters and liquids that are in there, use the right concrete mix so it will withstand the atmospheres that are, or the environment that they're exposed to. Get it right done the first time, do some tests, try it out, always measure, see if these things are holding out, and then before it breaks down on you, do it. Repair it, fix it. There was one example where a plant was built with this technology, and the people who were building it said, we're going to short sheet something. We're going to cheat on that a little bit and use lesser materials. Let's say there was a covering for some sort of device, and we said it has to be this kind of steel and this kind of coating on it if you're going to paint it. And they used a cheaper steel and a cheaper coating. 2 months later, it was rotten. It was corroded through. And so they had to take that off and now put in the next one, the right one. So it cost twice as much, and frustration, and it didn't work. They said, no, it did work if you use the right equipment. So a lot of thought in the beginning, or enough thought in the beginning to do it right the first time, you're going to make a lot of win-win out of it.
Does anybody else have any metrics they can share with us, just generally?
Sure. Yeah, I
Please.
mean, if you don't want to jump in, so remember, we're a gasification technology, so we're not the project developer. So we look at saying we license a process design package which would have specs for waste coming in, and we would deliver particulate and tar-free synthesis gas suitable for whatever the next end product conversion is. So that aisle we call it our gasification aisle for like 100 metric tons per day, would probably be in the range of around $25 million. That's it, but that's almost irrelevant because all the cost is in the project. I mean, we need oxygen. Where's the oxygen coming from? Are you doing all the waste up front, or are you getting waste delivered? What is that back-end technology? So that's why earlier I mentioned that project going to ammonia. We look at it more on, what is the sales price that end product is going to be. Right. And when you can share electrolysis and oxygen and electricity and all that other stuff, suddenly you're at an incredibly low hydrogen price. That's right. What matters to us more than just what is the gasification aisle. That's why greenfield is scary.
There's a lot of things that need to intersect to make it work, yeah.
Okay, so I just want to make sure one thing's clear on our end. We are a technology company. So if you're the city of Los Angeles and you come to us and say, can you build us a system to process our municipal solid waste? We're going to take a look at it and going to get data from you in terms of, does it make sense to separate the organics or not, or just take the whole thing as it is, or do whatever. And then we're going to build a plant. We're going to build it to your feedstock flow. Now we're going to commission it and train your people to operate it, and we're done. I mean, we'll come back for periodic, we're certainly there for help and things like that. But that's a little bit of a difference from the other people. We will build the plant.
So you're saying because you're not an operator, you're not necessarily...
We don't have the personnel to be operators in all different parts of the world and things like that.
But the CapEx and OpEx numbers, I'm sure for someone to evaluate a project to determine if it's going forward, I think that's what Daniel's getting at, is to be able to make a decision. They need some type of concept of where, and that also helps us determine where these projects will work, right? But depending on what we're getting for a tip fee in the area, what we can sell power or steam or whatever byproducts, fuel, the end user. There's a lot of factors. So just generally speaking, do you have some high-level numbers you can share? Even if it's just theoretical,
Right.
right on your,
So,
based on your.
tipping fee, if it's at or less than $8 a ton, and that's a pretty low number, or let's
Yes.
say $10 a ton actually, and if you can get a nickel for the power, again, I'm just keeping this simple, I'm not going to fuels and all that sort of stuff, but you pay back less than 5 years, okay? So you get more complicated, you want to get tires have a pretty high tipping fee. You know, there's all kinds of variation, but that's the easiest one for most people to get a handle on.
Scale is a huge part of that too, right? I mean, if you're doing 100 one gasifier, but you're putting 3 together and you share all the gas cleaning and all that,
Sure.
all of that really,
Yes.
really matters in a project.
Exactly. Economies of scale is very
Yeah,
key
yeah.
for all of these technologies by the sounds of it. Dan, do you have any comments in terms of the fuels? Like, what, are there certain targets that you have in terms of this is what it needs to cost us in the end per gallon in order for this to be feasible?
That goes back to the internal debate as to who's going to be, where's that carbon going to go? Is it going to go to chemicals or is it going to go to plastics? And it's whatever the most profitable vehicle is for that molecule. And no, I really don't have an answer to that.
And it's market dependent,
It's
and a lot of
market
it has to
dependent.
do with the carbon
Yeah.
taxes as well. Good, all right. I think we've lost track of your questions. Daniel, what was number 2 again?
Whether the biofuels are used by itself or usually have to be mixed up with hydrocarbon oil, which is sometimes part of the...
To be able to bring up the energy value? Do you guys have any comments on that?
Our fuel is good. I wouldn't have to mix it with another damn thing. I just use it. We clean it. If you want to make electricity, just use it. Jenbacher has approved it. If you want to do something else, then we get to talking about it. Do you have enough? Somebody said Fischer-Tropsch is a tad bit complicated. There's truth to that. So you're not going to have a tiny little system making fuel oil. But if you just want to make electricity, we're there. You don't have to do anything else.
So that
We're
the
there.
metrics you were talking about earlier were based on converting and recovering, making electrical power from steam?
Yeah, MSW.
Yes, but how are you producing the power? By burning the fuel
Oh,
or?
you're taking the syngas we produce
Syngas.
and running it. I mean, I just keep referencing Jenbacher. I mean, there's obviously Caterpillar and stuff, but Jenbacher has tested and approved our synthetic gas as a legitimate fuel for their engines.
Okay.
All right? Just as coming right out of the plant.
And there was a second part to that biofuels question, Daniel.
The other part was the industry tested the carbons as a byproduct to turn them into carbon fibers, nanotubes through the carbonization process. Is it something that the industry has been looking into, or is it just something not even?
We didn't get you on the
it's
mic,
not-
so can do you want to
Yeah.
just repeat that again so everyone can hear that? Thanks.
Yes.
Is it unmuted?
Hello?
Okay.
Yes, so my last part of the question is, we talk about biofuels and pyrolysis oil, but has the industry taken a further step and take a look into the carbons that are produced through this pyrolysis process? And I know there's the carbonization through the cross-linking, and you can produce nanotubes, carbon fibers that have a high market value. Is it something that the industry has looked into it, or this is something that there's no, so far, any technology that?
Are you guys familiar with any other useful byproducts besides the energy piece? Like doing some of these industrial,
Well, as I mentioned before, when we process something like coal slag, then you're going to increase the potency of, what do you call them, rare earth elements. But you still got to do work to get them. But they're
You're concentrating
Yeah,
them,
they're
essentially.
concentrated 6 times as much. I mean, we, just for what it's worth, we tried reaching out to Joe Manchin. I guess all you guys must know about him these days. And he's doing everything in the world to protect his state. And it's the biggest coal mining state around. And we could take coal, we don't care, and process it. It's pyrolysis. So we could make clean coal energy. You would think West Virginia would be falling all over us. And we can't get through the staff. So it's one more, government.
Back to government.
Back to government. We need God blessed government support.
We do have a lot, because we have a demo plant, a lot of people reaching out for synthesis gas to want to try and do things like ethylene glycol and other, we're not doing that because we're really trying to concentrate on the hydrogen, and we don't want to just demo stuff, but we do get people asking about that. We just haven't looked into it.
Yeah, that's a really good point to make, because yes, in the end, energy prices go up and down and incentives change, and if you can make other, high value industrial products like that, that could be really, really interesting too. So maybe we could talk a bit more about business models and different things that your businesses operate on, because you mentioned, for example, Michael, about the concept of being not being a developer, not taking on the whole piece. And I mean, I think that sounds good, because I can appreciate how taking on everything leads to technology companies getting into that valley. So maybe could you just talk a little bit about your business model, why you chose not to take on developer, what you do instead, licensing, and just that kind of thing. If you could talk about that, it'd be great.
Yeah, that was actually a big internal discussion. I mean, especially when you're talking with investors and you're trying to raise larger amounts, and if you put a bunch of build, own, operate, maintain projects in there, man, that line of revenue looks huge. And we're just not built that way as a company. We're a lot more engineers. We're not a project development team. And I think if you're going to be a project development company, you really need to be built that way. And we're not, and I think we're leaving a lot on the table, and that doesn't mean we won't go that way
Right.
At some point. For licensing, though, that allows us to partner with groups that, particularly the ones we're doing with now, don't have one project. They have 3 or 4. They're duplicating that same model,
Right.
for example, for ammonia. So we know we have a nice pipeline of licensing our gasifier and engineering services. We have proprietary lances and things that mean consumables in the project. Mm-hmm. That will be additional revenue. Also monitoring of systems.
Right.
There's some of that available. And my hope, ideally, would be at some point, you're much like the British Lurgy gasifier for coal, right? You're the gasifier they choose for mixed waste. And at that point, maybe you can get, you'd be equity into projects and things that way. And that would be down the road, but we got to get there.
Yeah, that makes a lot of sense, because I think when we talk about why a lot of these companies have disappeared over the years, a lot of times they've tried to go from being what they do great, which is developing a good technology that works. It's a whole other thing sometimes to even deliver a big project like that, even without sinking, because of course the technology risk is on you. You have performance guarantees that you need to meet, and that alone can take out a small company. But if you have to integrate all the other technologies,
You have project risk,
Right.
and that's scary.
and it can be huge, right? Even if the technical risk, the parts you can control, there's a lot of parts you can't. We're seeing that right now. Things were mentioned today, high cost of fuel, high cost of steel, high cost of manufacturing. So you're already taking on a big element of risk by doing that if you're building that piece. But if you have to build all the integrated pieces, air pollution control, material handling, whatever else you need, it can definitely sink a company. And I think it sounds like Shell is doing a part to that, to support some of these companies. These are companies that have proven out their technology, but you're bringing in engineering, as you mentioned, a lot of support to these small companies that are trying to do these so that they'll still be around tomorrow.
We did take equity in a company out of Europe. As far as the other dynamics in terms of biogas and RNG and that sort of stuff. That's a decision. It's project specific as to what we're going to invest into, but from pyrolysis from waste plastic is definitely an offtake program. If we operated the facility here in North America, it wouldn't do too well. We're a large corporation and things tend to run a bit slow. So that's one of the bigger challenges in being a corporation our size. But we're always open to looking at new partners and opportunities that they can present. But you got to demonstrate that, as I made the Shark Tank a comparison, you got to be able to demonstrate it and not just come with an idea.
Yeah, yeah, for sure.
To comment on that is just, so, but being an off-taker is great for financing, right? So you would, when you find the right technology, do a long-term off-take contract for them, and that gets them over the hurdle, which is, yeah.
Right, just having that contract.
Yeah, we do an LOI with somebody. If we found a technology and they can prove that it actually works, then we'd be more than open to do a long-term LOI, letter of intent. And the letter of intent would really help them obtain financing to help fund the construction and operation of the facility.
Good, yeah. And what about your company, Glenn? Do you guys do a development model or is it licensing?
It's mostly licensing. I'm licensed to bring this technology over from Germany, and we'll be looking for example, working maybe with other companies sitting here together, or working with large general contractors that would be able to build such a facility, MBT facility, something like a contractor that does wastewater treatment plants or similar. One who builds conference centers or malls wouldn't work. That doesn't make sense. But these other contractors that know, the local contractors that know their local rules, regulations, stipulations from state to state, know how to deal with them. I don't know it, and the German technology provider doesn't know it. So we need those smart people, smart contractors there that can build such a facility, and we would bring the technology over and work with them on that and license it to them from project to project.
And in Germany, is that applied as like a public-private partnership where both the government is investing in it as well as the developer?
The government from Germany wouldn't invest in it. Even the company that I used to work for, the ZAC in Germany, public company, or public meaning it belongs to the two counties, can't invest a dime. They can't do that, but they can do a technology transfer over. Oh. That's for sure. Yeah, okay. They can't invest anything. They're not allowed to. But they can do the technology transfer with their outfounded company and make a contract to do that with, let's say, a general contractor in the States or in Canada to build such a facility once a municipality comes along and says, we'd like to do it. Or work with other companies where it might be the feedstock producer for pyrolysis or gasification.
Anybody else have any questions? Or anything you'd like to contribute at this point? I think these are really some good things, and they're obviously some pretty hard challenges, and we're not going to solve them today. But when you look at what we're talking about here, you're seeing an interesting cross-section of different technologies and different project users, end users, and you can see how getting over that hump, getting that project financed, getting that technology developed takes a lot of money. But you know, it's the chicken and the egg scenario, as you mentioned. It's like those companies have to kind of stand on their own 2 feet to be able to show that they have a viable technology. And it's not maybe the role of industry to do that. And James mentioned he'd like to see more funding of these projects to commercialize them as well. And these are all good ideas. Does anybody have anything else they wanted to put in? Otherwise, I think we could wrap it up at this point in time, and get to the reception early a little bit, which it's been a long day, so I think everyone's probably going to be okay with that too. Yes. Well, actually, the next session that we do have going here is we're going to have a short thing on SWANA and the Waste Conversion Energy Recovery Technical Division. We're just going to have a quick meet and greet about that to follow this. So if we're good, if you're interested in staying in this room, certainly if you're a SWANA member, we definitely want to see you. Even if you're not and you're interested in SWANA and interested in the future of this conference, which will be integrated within the SWANA SOAR conference that's coming up, which is a technical conference. We'd love to see you at that in Atlanta. There's also going to be tours of at least one waste conversion energy recovery facility. So we'd love to come and talk to you. It's just going to be informal in this room and answer questions regarding the technical division and regarding SWANA. I'd like to just say to everybody in the room, the reason that joining SWANA is a good idea is the fact that SWANA is a pretty big organization. It's a fairly powerful organization, and I think what we're hearing here today is that there needs to be more voices for the industry in order to move things forward, and I think that's one important thing that SWANA does is you as a SWANA member, especially if you're involved in a technical division, you get the opportunity to have your voice heard. We write to government, we participate there in Washington, D.C., and they work on getting that message, what is it that you need done, and also as legislation and regulatory changes happen, SWANA has the ability to influence that, and you can be part of that as a member. But if SWANA represents a lot of different interests in the waste area, including hauling and landfills and everyone else, so in order to get the voice of the waste conversion energy recovery industry heard, we need to be there and be active. So that's kind of my 2 cents on it. So I'd like to just invite people to hang around, stay here, let's just chat about it. We're not planning to give a formal presentation on it, but just talk, answer questions, and talk a bit more about the committees that we work on and the important work that happens with SWANA Waste Conversion Energy Recovery. So thank you, everybody. Thank you for participating in this panel, and you're welcome to come up and meet with the panelists on one-on-one, and please hang around and let's talk about SWANA a little bit if you're interested. Thank you very much.
If I can say something
Sure.
before we're done with
Go
that. Thank
ahead.
you for doing that. I've been with SWANA since 2019 as a member, and now part of the WRSR, the Waste Conversion Energy Recovery Technical Division, and have at a number of times and a number of conferences spoken with David Biederman. He's our CEO. What do you call it? CEO and what's
Tim, what's his title?
Executive Director, CEO. And what I find amazing is you can get in touch with him, you can talk with him, you can touch him. He's a person he knows his stuff, he knows how to talk with the governments, he knows to talk with the individual people too. And he gives you a call. If you send him a question, you'll get an answer damn fast. Where do you find that in other associations? He's not up in the clouds somewhere. He's down in the ground looking for the interests of SWANA, interest of the companies that work and are part of the SWANA in the field, out there in the government. So it's a real pleasure to do some work with him to see how he also is encouraging the industry to work this way too. So if you're interested to come to our short meeting, we can talk about it. You're not going to be signing up. You're not going to be signing your life away or your firstborn or anything like that. But just to discuss a little bit about the waste conversion, energy recovery, technical division, and other stuff if you're interested too. Thank you.
Yep. Thank you. Thanks, everybody. Yep, that's it.